Assalamualaikum and good day. We are from group 11. So we introduce ourselves first. My name is Muhammad Afiq bin Tunan with my number 193769.
Okay, my name is Ammirul bin Md and my matric number is 192305.
My name is Muhammad Arduino bin Ruzian and my matric number is 19.
Our supervisor is Professor Madya Dr. Tang Sanfong and I are Razali bin Samin. Today we are going to present to you about integrated design project with our title Autonomous Flood Barrier with Water Level Sensor Program with Arduino. For introduction, flood was recognized in many parts of the world as the most common and damaging natural disaster. Every year, people in Malaysia, especially at Terengganu and Kelantan, currently face problem about the flood. The problem for the flood is it causes serious harm to individual, damage to property, and has serious effect on socio-economic activity. So the objective of the project is to analyze the prototype of flood barrier by conducting the simulation regarding the function of prototype and its properties, and to develop a prototype of autonomous flood barrier design that will manage to minimize property damage during flood disaster.
Okay, next for the methodology. First is a flowchart for the simulation step. First is design selection based on the first method. Then we design in the Kata software and also SolidWorks. Then the design is input into the ANSYS software, and also we do a step meshing and also get the mesh conversion to obtain the refined mesh. And in simulation software, we decide the boundary condition was set for the model to be simulated, and lastly we get the simulation result for the hydrostatic pressure, including the deformation, stress, and stress behavior. Okay, next. Okay, this is the flowchart for our overall project. First, we design the selection, first method, and selection. And the next step is the selection of material for flood barrier and its part and component. And we do the in laboratory, and also we get the dimension, suitable dimension, and suitable material. And after that, we coding and using the Arduino Uno. After that, we test the coding, autonomous flood barrier demonstration. And if the flood barrier is function, we do the marketing video for product design specification. And lastly is we do the final record presentation. Next slide. Okay, this slide show the graph for the mesh conversion. As you know, the mesh conversion is determined how many elements are required in a model to ensure that the result of analysis is not affected by changing the size of mesh. As you can see, this graph is total deformation versus the mesh element. The mesh element we set the 5,782 and it's become same for the total deformation until we increase the mesh element. So this element we decide to become our mesh element for the run simulation. Okay, next slide. This one we decide one by one for the element size, and we decide the 0.07. As you can see, the result for the total deformation is starting to same, and we decide this one element size 0.07 for our simulation. Okay, next slide. Okay, next slide. For the simulation, we apply the hydrostatic pressure towards the surface of barrier. And to decide this, we have to decide the fluid density was set to 1000 and the velocity is set to 2000. 200. Alright. Next. Okay, next we decide the fixed support for the boundary condition. As you can see for the figure 2, we decide for 5 space, include the barrier holder. To this one is to ensure that the barrier door was in static condition and only the barrier was moved forward by a motor on spur gear. Next slide. Okay, this one is a prototype component and parts. that have a barrier stand, barrier width rack, servo motor, Arduino Uno, and the figure 3 show the assemble for the autonomous flat barrier for our project. That's all for me. Thank you.
Okay, thank you, Ammirul. So next I will present about the result and discussion for this project. So as you can see that this is the hydrostatic pressure result when the hydrostatic pressure applied for about 200 meter per second square. The maximum hydrostatic pressure is at the top of the barrier, as you can see in the figure 4, with the 2.2686 to the 10 power of 7 negative 7 Pascal, and the minimum hydrostatic pressure, which is blue color, is at the center of the barrier with 2.2586 times 10 power of negative 7 Pascal. So next, this is the result for the total deformation. So as you can see that the maximum total deformation reached was 3.6534 times 10 power of negative 14. Meanwhile, the minimum total deformation reached was 9.9136 times 10 to the power of negative 18. So we can see that the red color is the maximum total deformation. Meanwhile, the blue color is the minimum total deformation reached. So okay, so this is the result of for the equivalent stress. So when we apply the hydrostatic pressure, the equivalent stress on the barrier showed the maximum equivalent stress, which was 5.3159 times 10 to the power negative 5 Pascal. Meanwhile, the blue color here showed the minimum equivalent stress, which was 8.1719 times to the power of 10 negative 7 Pascal. So next we will proceed to the marketing video and the testing of prototype. Okay, so this is for our marketing video and the testing of prototype. So based on the video here, we can see that the barrier is able to lift up and goes down whenever the water level sensor detect the depth of the water level. So when the water level sensor detect the water level, the barrier will lift up. And when the water level sensor does not detect any depth of water, the barrier will go down. The barrier will go down. So next is the conclusion. So in a conclusion, for our project, we can claim that the acrylic material prototype is suitable for flat barrier prototype since it can withstand the hydrostatic pressure as it does not damage based on the simulation applied. So I think that's all for our presentation. So thank you very much for your time.